All right, class. Yeah, all right, okay. I know no one's in here right now, but I'm still going to do that. Now, going through here, I am pulling this up. This is today's lesson. We get the notes. It's the same homework assignment that we have been doing, but I am going to do the next two problems, and one of them is going to be basically super easy, just plug in numbers. I might actually finish the last one too, and then just have Wednesday be a homework day, a day that you would come in Wednesday and we just work on problems. So that's my plan, and I'm sticking to it. So going through here, and if there's anything that you need or have questions about, just remember it's on Teams. So just go ahead and send me a message on Teams about whatever it is. Come back and forth on the video. Hit pause if you need more time on something. All right, right here it says applying sum and difference identities. These are the same things that we have been doing recently. If either A or B in the identities for cosine A plus B and cosine A minus B is a quadrangle, then the identity allows us to write in the expression in terms of a single function A or B. So quadrangle means it's on the x-axis or the y-axis. That's what that means. That's what here we go, quadrangle. Dang it. And I tried so hard not to mess up. All right, there we go. So it's on the x-axis or the y-axis. So right here, write this as a trigonometric function of theta alone. So this is a minus sign here. So that means it's going to be a cosine of 180 cosine of theta, and that's going to be a plus sine of 180 sine of theta. And so you know this is actually from your reference sheet. It's from the reference sheet or back in the earlier slides. You can back up in your notes. Now cosine at 180, so I'm going to pick these values off of my unit circle now. So cosine at 180 is going to give me -1 times the cosine of theta plus, now sine at 180 is going to be 0 times sine of theta. And anything times 0 is 0, so all of that right there on the right is going to go away. Because anything times 0 is 0, so that goes away. So my final answer comes out to be negative cosine of theta. Because -1 times cosine is going to give me that. And that's as a single variable, so we only have one variable. We have one value that we know and the value that we don't know, which is my 1 theta. All right, I'm going to keep going. So if you need more time on this, just pause the video, come back to it. All right, suppose you have sine S is 3/5, cosine T is -12/13. Both S and T are in quadrant 2. Find cosine S plus T. Now, we actually have two angles that we're using here. So I'm going to start with S. We have X, Y, and R. And if you remember these, we did these a long time ago back in unit 1 and 2, I believe. So we're going to have X, Y, and R for angle S. So sine is supposed to be y over r, so my y value is 3, my r value is 5. So I'm going to use Pythagorean theorem to find my missing unknown value. So both S and T are in quadrant 2, so that's going to tell me if it's going to be plus or minus. So if you notice, here's in the diagram right here, I have that in this value, this is my y value here, this is my r value here, and this is my x value. So in quadrant 2, which this is, we know that the x value has to be negative. Quadrant 2, x value is always negative, so that's what I'm going to get that. Now, Pythagorean theorem, I have x squared plus y squared equals r squared. So x is my missing value, so I keep x squared plus y, which is 3 squared equals 5 squared. X squared plus 9 equals 25. Subtract 9 from both sides, and I get, come on up, bring this down, I get x squared is equal to, so 25 minus 9 is going to give me 16, and undo a square, I'm going to square root both sides, so x equals plus or minus the square root of 16, and in this case right here, 16 is a perfect square, and it tells me over here on quadrant 2 that x value has to be negative. So this is going to give me that x is equal to negative 4. So that takes care of s. That's x, y, and r for my s. Next thing I'm going to do is my t's. So I'm going to go to the next page. I'm going to do my t's, where cosine t is equal to negative 12 over 13. And this over here is in quadrant, I'm going to do t, is in blue now. So this is going to be in quadrant 2, and in quadrant 2, we know the y value is positive, the x value is negative, and r is always going to be positive. So x equals y equals r equals. So for cosine, cosine is just x over r, and since I know that my x value is negative in quadrant 2, the negative has to go with the 12. It doesn't go with the negative goes with the 12 because it's the x. That won't go with the 13 because the 13 is my r. My r value is always positive. Like that. So we're filling it in. Pythagorean theorem again. So I get parentheses, negative 12 squared. So now this is key. I've been watching people do their math and they keep messing this up. Don't mess this up no more. So right here, when you square this and you have a negative, make sure it's in parentheses like this, just like this. Otherwise, you're going to mess it up. I don't want you to do that because you're going to end up having a negative value there where you don't want to mess that up. Because when you square a negative, it becomes positive. Equals 13 squared. I get 144 plus y squared equals 169. Subtract 144 from both sides. So y squared is equal to 25, and right here we're going to get y is equal to plus or minus the square root of 25. Now, since we said that y is positive in quadrant 2, that means the square root of 25 is going to be a positive 5 right there. So I get a positive 5 now there from that. So now for us, what we are doing is, so now I have all my values for x, y, and r for my t. Now I'm going to go back to the original problem because this is a little bit longer. And for this one right here, both s and t are in quadrant. Find cosine of s plus t. Cosine of s plus t. There we go. So we're finding cosine of s plus t. So I'm going to expand this using my reference sheet. This is going to go cosine of s, cosine of t, minus sine of s, sine of t. Now I'm going to go through and just pick and put in my values. So these ones where I have been doing were values on my unit circle. These are not on my unit circle. I need to use my x, y, and r from my other page that I just made. And for the sake of argument, I am going to carry it over. So we said t was x was negative 12, y is 5, and r was 13. Now for s was negative 4, 3, and 5. Just like that. Now, I'm going to go through and start filling this in. So I'm going to replace cosine s, so I'm looking at s value right there. Cosine is supposed to be x over r, so this is going to be negative 4 over 5. And this next one over here is sine. Sine of s is y over r, so that one is 3 over 5. Now I'm going to change. So this next one is going to be cosine of t right here. So cosine of t. So I'm replacing that one. So I go to my t, which is in blue. Cosine is x over r. So negative 12 over 13. And there's my minus sign again. And I have sine of t. Sine of t is y over r. So it's 5 over 13. Now, I can actually just do my multiplication here. Do the multiplication. Remember, when we multiply in fractions, we multiply straight across. And I got negative times a negative is going to be a positive. So this negative and this negative becomes positive. 4 times 12 is going to give me 48. 5 times 13 is 65. Minus sign. Now, I'm over here. 3 times 5 is going to give me 15 on top. And on bottom is 5 times 13 is 65. Now, I have a common denominator of 65, and I can go ahead and just do the numerator now. So 48 minus 15 is going to give me 33 over 65 as my final answer. Again, if I went too fast, pause it, go back. Trying not to leave too much extra dead time in this video. Alright, so I'm going to go on to the next one. So this next one right here, applying cosine difference to identity voltage. So what this is doing is common household electricity currents called alternate current because the current alternates direction within the wires. The voltage V, typically 115 volt outlet, can be expressed as this function right here. So these are all going to be like some type of word problem type of thing, where W is the angular speed, radians per second, of the rotating generator at the electrical plant, and T is time measured in seconds. Okay, so this is actually real math, real application of this. So we have a couple variables here that we're going to deal with. We're looking for a W and a T. It is essential for electricity generators to rotate precisely 60 cycles per second. So 60 cycles per second, so it's 60. It rotates, so that's what a cycle is. That means a full rotation. That's going to be 60 times 2 pi, where I'm down here. So 60 of those, 60 times 2 pi per second. So every second it does that. Determine W for the electric generator. So for this, and we get, so it's going to come out to be a 60 times 2 pi. So my W, what I just found was 60 rotations, and each rotation is 2 pi. That's going to give me 120 pi. And that's radians per second. So these are just going to be a plug-in type of problem. Here's what it looks like on a graph. And for any value of t that we're looking for here. Determine the value of theta, so graph of this cosine of wt minus theta is the same as the graph of this one here as sine. So, for this one right here, we're going to go through and just fill it out because we know what these are, and I want to figure out what it is for sine. I don't know what this is, but I will in a moment. So I know this is a minus, so it's going to be, let's see, cosine of a plus b. No, I'm sorry, cosine of a minus b. Sorry. I even said that, but still, minus b. Cosine, in this case, is going to become the first one, so that's wt minus cosine of theta sine. Why do I keep messing this up? Plus sine of wt sine of theta. So all I did is I'm using that same identity, but since I know what the value of wt is, so we're going to try and figure out what the theta is going to be. So from my previous one, did it back up too far? Oh, there it is. Ooh. Hey, I figured out why I kept messing that one up. So let's go through and plug these in for the values that we had. So sine wt, and wt was going to be my, what did we say? That was 120 pi. So 120 pi So we're plugging in all these values that we know to find something that we don't know. And 120 pi is going to end up becoming a positive 1. It's going to be a positive 1. Because this on my unit circle, so if I keep doing this over and over again, looking at my unit circle, I get 0 pi, I get 1 pi, this one's back over to 2 pi, this is 3 pi. So as I keep going and I keep going around my circle, it's going to keep, every even number is going to end up on the right side, where every odd number is going to end up on the left side. So 120 is an even number, so that's going to give me back there at 0. where that's going to give me 1. So it's going to give me 1 cosine of theta plus sine. Now the sine value over here is, because this coordinate is 1, 0, the sine value is going to be 0. And again, anything times 0, anything times 0 is 0, so that's going to go away. So we're going to end up with right there. And that's all of this right here redone. So it's going to be, for this, it would be 1 So if you notice, it's not W theta, it's just of theta. And of t, sorry. Let me try this. Make this a little bit easier, otherwise. I know this might seem weird, me talking to an empty class and showing you how to do this, that they will match. You'll see it here. So we want this one to equal the cosine. So here's the sine, I want it to equal the cosine.